Hi there. Welcome to Module 4, Lesson 10 of Engage New York. This is the concept development portion of this lesson. Read the objective while I read it out loud. I can compare and evaluate expressions with parentheses. So the big idea with this lesson is, can I either look at a model and write the expression and solve? Or can I look at the expression, put it into a model, and also solve? So what we're going to start off with is looking to see what we have here. So 9 plus 11, so this whole tape diagram is equivalent to 9 plus 11. But we know there's a fraction to this problem. And this problem is broken up into fourths. And what portion of the fourths are we trying to find? 1, 2, 3 of the fourths, right? All right, so let's start off with, what do we call the answer to an addition sentence? What do you call the answer to an addition sentence? You're right, it's called the sum. Right, the sum of two numbers. So our whole is the sum, so this whole is the sum of 9 and 11. So how many units is the sum being divided into? 1, 2, 3, 4, right? What is the name of that fractional unit? It's called fourths, right? This is just a reminder. How many fourths are we trying to find? 3 of the fourths, right? So this tape diagram is showing 3/4 of the sum of 9 and 11. So what we do is we write a numerical expression to match what we just said. So first of all, 9 plus 11, well, we know is 20, but that's not really what we're working with right now. You have to use what's given to you. All right, so let's put this. So I'm going to write this. You can write this 3 different ways, and it's still correct. So I'm going to use some parentheses. 9 plus 11 times what? 3/4. Now, another way to write this would be 3/4 times 9 plus 11. And there's one more way to write it. Do you know what it is? And these all are going to give us the same exact answer. They mean exactly the same thing. 3/4 of 9 plus 11. 9 plus 11 times 3/4, right? Or 9 plus 11 copies of 3/4, right? Here, so let me show you the third way, unless you've already written it. You could have written it that way as well. All right, so now we are going to evaluate. Evaluate means solve and the expression. So let's go here. 9 plus 11 is 20 times 3/4, which is exactly what we've been doing. Multiplying a whole number by a fraction, a fractional unit, right? So 4 goes into 4 once, 4 goes into 20 5 times. This is equal to 15. So this 3/4 is equal to 15. Now, if you divided 15 up into 3, 1, 2, 3, what would you get? 5, right? And then when you stop and think about that for a second, the sum of this was equal to 20. So if you were to break it up into fourths, 5 times 4 is 20 anyway. So it matches up. The same exact thing you would do here, would be 3/4 times 20. And you'd end up with the exact same answer. Then here, you would end up with 20 over 4 times 3. 4 goes into 4 once, 4 goes into 20 5 times. 5 times 3 is 15. All right. This is the big idea right here. Taking the problem and putting it into words, putting the diagram into a numerical expression. We're going to be moving through that. Now, look at this model. How is it different from the previous example? Well, this time we don't know what the whole is, right? In this diagram, the whole is being divided into how many? 1, 2, 3, 4, 5, not fourths. So here we know that 1/5, we do know what 1/5 is equal to. We know it is the difference between 1/3 and 1/4. So we have to multiply the difference. We have to multiply the difference by 1, 2, 3, 4, 5 to find the whole. So let's go ahead and try that. So if we were to write this out, this would be 5 times 5 times the difference of 1/3 and 1/4. All right, so you're ready to try this out? So these words are the same, mean the exact same thing as this model. So here we go. So if we go 5 times, now we're going to put the words into a numerical expression. 5 times 1/3, and it says the difference. What is the difference? Subtraction, right? Of 1/3 and 1/4. So before we can do anything, we are going to go ahead and solve 1/3, subtract 1/4. So can you subtract two fractions that don't have the same denominator? No, you have to create a common denominator, right? So I'm going to multiply by 4 here. I'm going to multiply by 3 here. And I'm going to get 4/12, subtract 3/12, right? So 5 times 1/12. Are you with me? All right. I'm going to add the equal sign. All right, then we could solve this in two different ways. We could go 5/12, right? Because that's 5 times 1/12, which is going to give us 5/12. So this section right here is equal to 5/12. So now you have to take 5/12 and do what with it? Well, you have 5 units of the difference between 1/3 and 1/4. So, oh, we already did that. Sorry. Just kidding. We already did it 5 times. So, 5/12 is 5 units of 1/3 minus 1/4. All right, now tell me, I wonder if you could take this problem and show me in one other way. Is there another way to write a numerical expression to match these words? Think about it for a second. Is there another way that we could write this numerical expression to match the words? Well, hopefully you wrote something out. So instead of 5 times 1/3 minus 1/4, could you have done 1/3 minus 1/4 times 5? Because this here is 1/12. 1/12 5 times. Which equals 1, 2, 3, 4, 5. This whole tape diagram is equal to 5/12. Sorry, I got myself wrapped around the axle there. I forgot we had already multiplied. All right, so the difference between 1/3 and 1/4 is 1/12. Then we multiplied it by 5 and got 5/12. 1, 2, 3, 4, 5. All right, so the second way we could have written this problem is 1/3 minus 1/4 times 5. All right, we're moving on to the next problem. So here I didn't use any words, but could we put this into words? We could write what? What would you do? How about the sum of, we could do the sum of 9 and 11 times 3/4, or you could write up here, since I wrote the words here, let me write the words up here. 3/4 of the sum of 9 and 11 is probably the best way to write that. 3/4 of the sum of 9 and 11. That's what we're looking for. All right, let's keep going. The product of 4 and 2 divided by 3. So now we're going back to, we're going to go ahead and start with the words this time. So we're going to write and evaluate an expression from the word form. So the product of 4 and 2, the product. What does product mean again? Product means multiplication, right? So the answer of 4 multiplied by 2 is then what? Divided by 3. So what is that going to look like in a problem? Okay, so try something. Show me, write down right now, the product of 4 and 2. What does the product of 4 and 2 look like? Okay, the product of 4 and 2, right? Then we have to do something else. So first of all, I'm going to put parentheses around that. The product of 4 and 2 divided by 3. Now you could write it a couple of different ways. You could write it 4 times 2 over 3. And you could technically write it without the parentheses. All three of those ways work perfectly perfect. Now, the parentheses were not necessarily necessary because the product came first and we can do multiplication and division left to right. Remember PEMDAS? All right, so we didn't need to use them, it's just a habit to get into of telling someone or indicating what operation you're going to do first. So, how can you evaluate this expression? And now I turn it into an equation by adding the equal sign. So what would it be? 8 divided 3. What would that give you? Well, if you could go like this, right? So 2 2/3. This is equal to 2 2/3. So let's review. The product of 4 and 2 divided by 3. The product of 4 and 2 divided by 3. The product of 4 and 2 divided by 3. All right. I think that's going to do that on problem 3. Moving on to problem 4. Now, problem 4 is we are going to compare expressions in word and numerical form. So, we're going to evaluate and compare equivalent expressions. That's what we're doing right now. I jumped ahead for a second. So, before we start comparing these, let's go through and evaluate and before we start comparing them. So we have 2 divided by 3 times 4. What do you think we should do first? Now remember PEMDAS. So parentheses, are there parentheses here? No. Are there exponents? No. Is there multiplication? Yes. Is there division? Yes. But whichever one comes first, because multiplication and division are equal, you just do whichever one you come to first. All right, so 2 divided by 3 times 4. Is that what you got? So 2 divided by 3 equals 4. So you could also do 2 times 4 over 3, right? And end up with 8/3, which we just solved up there, which we know is 2 2/3. All right, let's go to B. 4/3 doubled. What is 4/3 doubled? What does doubled means? It means times 2, right? It's twice itself. So 4/3 times 2. Well, that kind of looks like that, doesn't it? 4 times 2 over 3. Look at that. It gives you 8/3 again. This is interesting. This is written as 2 divided by 3 times 4, and it ends up looking like this, ending up like this. 4/3 doubled. 4/3 times 2 is equal to 2 2/3 as well. All right, now let's go to C. Well, this one, 2 divided by the product of 3 times 4. So 3 times 4 is 12 over 2. So this equals 6, right? All right. So what's the difference so far about A, B, and C? Well, A, B are the same. They're actually the same equation, right? Or expression, if you will. But 6 is different. Since the expression had parentheses, we had to multiply first and then divide. It was equal to 2/12. 12 halves. In expression C, all of the numbers, digits, and operations are the same as the other expressions, but the order of the numbers in parentheses resulted in a different value because here, right? So we had to do multiplication first and then divide by 2. And we realized that because these are exactly the same numbers, but because the parentheses were there, it changed the way we had to solve the problem. By having the parentheses, we had to multiply first and then divide. All right, so now let's go back here. This is exactly the same. Look at this. 2 times 4 over 3. It gives us 8/3 again, which gives us 2 2/3. All right, part E. 4 copies of the sum, so 4 copies of the sum of 1/3 and 1/3. So let's write that out. 4 copies, remember we've been practicing with that verbiage, of the sum of 1/3 and 1/3. Well, what does that equal? 4 times 2/3, right? Which is going to give us 8/3, which is equal to 2 2/3. So, in expression C, all the numbers, digits, and operations are exactly the same as the other expressions, but the order of the operations, the order of the numbers change because of the parentheses, right? So, since the expression had a parentheses, we had to multiply first and then divide. Understand? Hopefully that is you're totally understanding how these are all the same. They're written just a little bit differently, but these expressions result in the same answer. All right, on F, 2 divided by 3 becomes 2/3 times 4, which is 8/3. 2 2/3. So let's look back and compare these expressions. 2 divided by 3 times 4. So 2 divided by 3, we had to start with this lot before when we started up here because division and multiplication are equal in value or in their placement in the order of operations. The order of operations states that division and multiplication are equal. So if you have multiplication and division in the same problem, whichever one you run into first, starting from left to right, is the operation you do first. 2/3 divided by 3 times 4. 2/3 times 4. 2/3 times 4. 2 divided by 3 times 4. 2/3 times 4. 2 times 4 over 3. 8/3. 2 2/3. 4/3 doubled. 2 divided by, 3 times 4 has to come first, and it's divided by 2. Then we have 2/3 times 4. So you can write it like this again. 2 times 4 over 3, 8/3 becomes 2 2/3. Then 4 copies of 1 1/3 plus 1 1/3 becomes 4 times 2/3. 8/3, 2 2/3. Here is exactly the same problem as A, but they put the parentheses to show that they want you to go do that first. 2 divided by 3, 2 over 3 times 4. 8/3 is 2 2/3. All right, the last couple of problems here. Now on problem 5, what I'd like you to do is I want you to find another independently I want you to find another way of expressing 3/5 times 6. 3/5 times 6. What are 1, 2, 3, 4? Could you do 4 different ways? 1, 2, 3, 4. Could you do 4 different ways of expressing exactly the same expression? Now, you're going to look back at problem 4 to help you with problem 5. I want you to try this and do not restart the video until you have all 4 ways. Don't give up. And I want you to try all 4 ways before you come back to check your answer. All right, so how did you do? Let's look at a few different ways. So I pulled the 3 off and I did 3 times 6 over 5. 3 times 6 divided by 5. 3 times 6 divided by 5. 6 times the value of 3 divided by 5. So 6 times the value of this, 3 divided by 5. Okay, this is the mid-module test is coming up, and this is going to be on it. So definitely go back and rewatch if you need a little more help. All right, our last problem is we're going to compare expressions in word and numerical form. So before we were taking the expression and expressing it in other ways, right? We were expressing it in equivalent expressions. So these are all equivalent expressions to 3 over 5, 3/5 times 6. All right, now we're going to use the compare signs in order to decide which one of these is bigger, which is smaller. So 1/8 the sum of 6 and 14. 1/8 the sum, so the sum of 6 and 14. So we know 6 plus 14 times 1/8. Okay. So it's easier if you take the problem and write out the problem before you solve. So you have to evaluate these before you can use your compare and contrast signs. That is my little nugget of knowledge. Are these the same? Interesting. Because where would that 8 go? Where would that 8 go? All right, 4 times 8 over 3. 4 times 8/3. So 4 times the quotient of 3 and 8. 3 times the quotient of 3 and 8. What is that going to look like? What is that going to look like? Is that going to be the same? Okay, then subtract 2 from 1/2 of 9. So 1/2 times 9. This is exactly what we've been doing, right? 1/2 of 9, 1/2 times 9. So I'm going to subtract 2 from this, right? All right, so now I've helped you set up your expressions. What I want you to do is I want you to solve both sides of the expressions, both sides of the compare and contrast, and I want you to use your compare and contrast signs to label your statements here, okay? Then come back and check your work. All right, so technically you could have compared these expressions without calculating, because if you just realize that this problem 1/8 times 6 plus 14 is the same as 6 plus 14 divided by 8, you would automatically know without even having to evaluate or solve that they were equal. but you have to be able to realize that those are equivalent. Then we have 4 times 8/3. So both problems multiply something by 4, right? And since 8/3 is greater than 3/8, the expression on the left is larger. Since both expressions multiply with a factor of 4, the fraction shows that the smaller amount results in the product that is also less. All right, then we subtracted 2 from 1/2 of 9, and 11 divided by 2 is going to actually give you a greater fraction than 9/2. All right, so then you were able to evaluate that and say that this problem is going to be greater because 11 divided by 2 is going to be 11/2, which is going to give you 5.5, versus 9/2 is going to give you 4.5. All right, that's going to do it for this part of this lesson. This was the concept development 4-10. So now let's take a look at the problem set before you get started. So write expressions to match the diagrams. So very similar to what we started with. Look back at your notes to show you as a model, to model how you should write the expressions to match the diagrams. And remember, you're writing the expression. Then evaluate. So write the numerical expression, evaluate, which means solve, right? Write an expression to match and then evaluate. So you're taking the words and putting it into the numerical expression. And this, yes, you're evaluating. Same. And I'm pretty sure these problems go along with what we just did in concept development. Then we have circle the expressions that give the same product as 4/5 times 7. So yeah, you're probably going to want to go through and solve this and then go through and find the expressions that have the same product. Sometimes you can just look at it and then you're going to explain how you know. How did you know? It's just going back to what we said earlier in the lesson when we said, okay, they both multiply something by 4. Since 8/3 is greater than 3/8, the expression on the left is larger. So something like that to explain how you know. How did you know that this problem worked? How did you know this problem worked? How did you know? How did you know? So just nothing really long, just being able to tell me, explain yourself. How did you know this equals this? All right. Then we have, to end this here, you're going to use the compare and contrast symbols to evaluate the numbers. And it says without calculating. So I always like to calculate because I like to make sure, but I think they want you to use your reasoning, explain your thinking, just like we did earlier when we spoke about it. Oh, no, there's one more problem. All right. Colette bought milk for herself each month and recorded the amount in the table below. For A through C, write an expression that records the calculation described. Then solve to find the missing data in the table. So if she bought 1/4 of milk of July's total in June, she only bought 1/4 of July's total in June. What would that be? So you're multiplying a fraction by a whole number a lot of times. She bought 1/3 as much in September. In April, she bought 1/2 gallon less, then twice as much. So your explanations will vary, but how you go about to solve this is going to be important. So now display the data from the table in a line plot. Remember what a line I would have January, February, March, April, May, June, July, August, September, October, and then you're going to have the amount in gallons. I would go month down here, gallons here, to show that table. Remember, a line plot is the dots, and then you can connect the dots. How many gallons of milk did Colette buy from January to October? So that sounds like a great addition problem of a lot of fractions and whole numbers right there. And I tell you, I believe there's a problem exactly like this where you have to add up all the data, all the fractions in the chart for the mid-module test. So Colette bought milk for herself each month and recorded the amount in the table below. Write an expression that records the calculation described. So she bought 1/4 of July's total in June. So 1/4 of July for June, using the numbers that you have in the chart. All right. Once you finish the problem set, come back to check your work because, as you know, the problem set goes exactly with the homework. And all of these types of problems that you see in the problem set and in the homework really and truly prepare you for the test. All right, good luck. And then come back and check on your answers.